So when you finished the last activity, this is what I had you do. Most importantly, I want us to make sure that we understand what's happening here in order to make sense of it, because there is a lot going on in each of these problems. So we're going to, hopefully we can do this together. This would be notes, just a little bit before you have to do a little bit more activities for homework. But take a look. Last class we were discussing a couple of things about problems that looked like this. Well, I can't undo addition and subtraction, but check it out. I've got right here and right here, I've got two like terms. I've got 3x and 2x. So, but 3x and 2x, I know that. That's like having 3 bags and then 2 bags. How many bags do I have altogether? I have a total of 5 bags, and then the minus 4, there's still those negative 4 blocks, equals 7. Well, all I've done here was combine like terms that happen to stay on the same side of that equal sign. So that equal sign isn't changing. And then what can I do? I can undo PEMDAS backwards. Remember, PEMDAS backwards. PEMDAS backwards will help us solve. So if I want to undo addition or subtraction first, I have to undo that minus 4. So I'm going to add 4 to both sides. So add 4. 5x equals 7 plus 4 is 11. And then I have to undo multiplication or division. So undo this multiplication. So what did I do? In the red step, I added 4 to each side of my balance. And then next, to undo that multiply, I would divide by 5. I could divide by 5. Or, if you want to get really fancy, we could just make this into a fraction. Divide by 5. Divide by 5. And I think this is where we need to go. The 5's cancel out. So then I divided both sides by 5. Both sides by 5. My answer is x equals 11 fifths. Wow, that doesn't feel very satisfying, but it's a correct answer. And if you wanted to, you could reduce it into a decimal, and you would probably get 2.2. So if you got the decimal version, 2.2 is also okay, because 11 divided by 5 is 2.2. This next one is a bit tricky because there's lots and lots of fractions, and we can use our fraction skills to attempt this problem. It's a little bit tricky though, so hang in there with me, please. To accomplish this, we're going to have to revisit some of our fraction skills. So I'm going to first try and make this as organized as possible. I'm going to put a big blue line or a big black line or whatever line to separate the left side of our balance, the equal sign, to the right side of our balance. And remember, these are always going to stay balanced at every single move. And I see that I have x's up here. I see that I want to combine them, but I'm not entirely sure how I want to do that yet, because I've got all of these fractions floating around. I'm going to zoom in here so we can all kind of see it a little bit better. So 3x divided by 4 minus 2x divided by 3 plus 5, 6. I'm going to undo that addition and subtraction first. So I'm going to subtract 5 sixths, subtract 5 sixths on both sides of my equal sign. And so I'm going to subtract 5 sixths. So this is going to end up being, everything else just copies down. 3x divided by 4 minus 2x divided by 3, this canceled out, equals 1 minus 5 sixths. Oh, well, 1 is a funny version of 6 over 6, so this ends up being, I just converted that 1 into a fraction, so 6 over 6 is also 1. 6 minus 5 is 1 sixth. Okay, so now from here on, we're going to use 1/6 moving forward. So 3/4 x minus 2/3 x, or 2x over 3. We need to have a common denominator to multiply these. So the first thing we need to do is multiply by a funny version of 1. Well, 3 over 3 is a funny version of 1, and so is 4 over 4, also a funny version of 1. So in my process, my step 2 is to get a common denominator. So I know it's really tempting to cancel things out, but 3 times 3 is 9x, and 3 times 4 is 12. Minus, keeping that minus sign there, 2x times 4 is 8x, and 3 times 4 is 12. Oh, this is super nice, because now I have common denominators, and that is equal to 1/6 that we got from before. So from up here, this comes down to there. When a common denominator happens, I can just combine them. So I keep the denominator the same. And I add the numerator. I add the top of the fraction. 9x minus 8x is just 1x, equals 1/6. So in this step, I combined like fractions with the same denominator. I combine like fractions with the same denominator. So if 1x divided by 12, oh, we don't even need that 1 in front there, do we? It's just 1x, it's just one of the x's. And if I have something divided by 12, we talked about this just a few minutes ago, undo the division is multiplication, so multiply by 12, multiply by 12. So I multiplied by 12 on both sides. 12 divided by 12 goes away. I'm left with x equals 1/6 times 12. If I have 12 sets of 1/6, I have 12 over 2, or excuse me, 12 over 6, I have 12/6, that is 2. So x equals 2. And all I did in this last step, from here to here, was reduce the fraction. Sorry about that, my phone went off. So I'd like you to try the next couple of problems on the next few pages by following these steps. Some of them are more challenging than others, and I know you can do it. As you're doing these problems, make sure that you're combining like terms. So combining like terms or distributing to each thing. And don't forget you're distributing here a -2. We'll come back. My goal is that you finish this as homework and that you can come back ready to go. Thanks so much. I hope you have a great day, and I expect a fantastic report from your class. Bye-bye. If you ever need to view these videos, you can always go onto my website. My website is mr.germanus.org, and this video is posted on my YouTube page as well, and that is viewable through my website. Right within it says November 13th substitute file, and it is all right there. I will see you on Thursday.